Good afternoon. Thank you for having me here today, Jill. I just wondered if we could start with an initial show of hands. How many of you are from outside Vermont? All right, that's helpful. For those of you who are from Vermont, there may be some information you've heard before, but wanted to make sure we sort of had a common starting place for the panel discussion that will follow. So I'm going to provide a brief overview of Vermont's Clean Water Act. This map on the right-hand side of the screen shows the 15 major river basins that we organize our work into here in Vermont. And what's really notable, as we step to the next slide, where I'll talk a little bit about what a total maximum daily load or pollution budget is that with the exception of this bright green watershed down in the lower left-hand corner, all of the rest of these watersheds are subject to at least one TMDL. And so when we're talking about TMDLs, we're talking about a pollution budget, and it's really the maximum amount of pollution, or of a pollutant, that any surface water can receive and still meet standards. So when we talk about Lake Champlain, people typically are thinking about phosphorus pollution. Lake Memphremagog, also phosphorus pollution. The Connecticut River drainage, it's nitrogen pollution. But we also have a number of smaller TMDLs, ones that look at stormwater as a pollutant, places that are impaired for E. coli or for chloride contamination. So it's pollutant specific and water body specific. And what the TMDL does is very much like a financial budget, is allocates the available load to different sources. So it can be to different jurisdictions. In the case of Lake Champlain, we're talking about Vermont, New York, and Quebec. It can be to the different river basins, going back to this slide, breaking it up into the Winooski, the Lamoille, and the Missisquoi. And we also look at point sources, things like wastewater treatment plants, where the discharge comes out of a pipe, and non-point sources, where the pollution is diffuse, and often you think of caused by rainfall and runoff from the land. And this is what phosphorus pollution can look like, sort of in its most extreme. This is a photo that was taken in Missisquoi Bay a couple of years ago, and this is a blue-green algae bloom, sort of in full force. They are both unsightly, they smell terrible, and can produce toxins that can have human health impacts, as well as we have incidents of a couple of dogs falling sick or even dying after having swum in contaminated waters. So this is the condition we're trying to avoid, or in some cases remediate at this point. So in addition to sort of that image, there are a number of other reasons we need clean water. First is for our use and enjoyment. Surface waters here are used for swimming, for boating, for fishing, and for drinking. Almost 250,000 people take their water out of Lake Champlain. We also have the governor is fond of saying the environment is our economy here in Vermont. More than $2.5 billion a year is spent on tourism here. And so our surface water bodies are a key attractant, and therefore it's really important to keep them looking their best. It's also a property values piece. There's work that's been done by UVM within the last couple of years that showed a decrease in lakefront property values as a result of correlated with decreasing water clarity. And so it's important to the people that live on the lakefront, in addition to those that visit the lakefront, to have high quality waters. And then, frankly, it's integral to our brand. We are green mountains and blue waters, not green waters. So I just want to give you a little bit of a sense for each of the three major watersheds within Vermont. The first is the Lake Memphremagog watershed. And I'm going to hit Lake Champlain last because we sort of have the most detail on that at this point. Lake Memphremagog is a fairly significant cross-border lake, and what's interesting to note, and I'm not sure it shows up very well in this image, you can see it in the top though, most of the lake is in Quebec and most of the watershed is in Vermont. And this is a very high-value recreation lake for the province of Quebec, and one that they're paying quite a bit of attention to. It's a deep lake. It gets as deep as 350 feet, and is a drinking water source for, again, over 200,000 people, most of them in the province of Quebec. So we have prepared a pollution budget for Lake Memphremagog as an agency. It was released for public comment earlier this spring, and it found that we needed to reduce phosphorus loads in the lake by 29%. And that's a pretty significant amount, but I want you to keep that in mind when we get to the Lake Champlain TMDL. And even if you can't read what each of these different colored wedges is in the back, what it's showing is each one of them needs a reduction. The reductions vary depending on the sector. We're looking for a significant reduction from agriculture and developed lands, which are the green and orange wedges, and a less significant reduction from some of our impaired natural resources, like wetlands that have been impacted over the course of time. All told, we're looking for a 41 metric ton reduction, which is up over 8,000 pounds a year. In addition, the entire eastern half of the state of Vermont drains into waters that eventually make their way to Long Island Sound via the Connecticut River. The image is actually of Long Island Sound. The Connecticut River comes in over to the right-hand side of that image. And those red areas are areas where there isn't enough oxygen in the Long Island Sound. Sometimes that's called a hypoxic zone. But when there isn't enough oxygen, things can't live there. And so if you're a fish or something mobile, you move on to fairer waters. And if you're a mussel or something else that's on the benthic bottom of this area, unfortunately, you often die. And so this is a multi-state effort being led by EPA. There are discharges in Vermont, New Hampshire, Massachusetts, Connecticut, and New York that all reach the Long Island Sound. And EPA is preparing a TMDL document as we speak, and we expect to receive some updated allocations or our share of the load from EPA in the coming months. And then Lake Champlain, and I understand Vicki Drew touched on a little bit of this Lake Champlain history earlier today. So just briefly, the real heightened focus on Lake Champlain in Vermont started in 1996 with the Lake Champlain Management Conference, and this led ultimately to the formation of the Lake Champlain Basin Program, which is an important quasi-federal partner that helps coordinate the work between Vermont, New York, and Quebec relative to Lake Champlain. Vermont and New York worked collaboratively on the original pollution budget for Lake Champlain that was approved by EPA in 2002. Because of international governance issues, we actually have a separate offline agreement with the province of Quebec, where for the purposes of the TMDL, the state of Vermont accepts their portion of the load, and then we allocate it to them under a separate agreement. In 2010, actually while I was working at the Agency of Natural Resources, we revised the Lake Champlain implementation program. There had been a number of questions raised about our schedule and a desire to see a heightened degree of specificity in the types of projects we propose to undertake to implement the TMDL. And so we issued that revised implementation plan in response to a directive we received from the legislature. But in 2011, EPA revoked their approval of the TMDL anyways. And it took a number of years to get back to the point of having an approved TMDL. And in fact, that didn't take place till just about a year ago right now. In the interim, however, and as Vermont was working with EPA on the TMDL, the revised TMDL, our legislature in 2015 passed Act 64, which we refer to as Vermont's Clean Water Act, and it has a number of provisions that support the ultimate implementation of the Lake Champlain TMDL and will support the work we need to do in the Lake Memphremagog watershed as well as the Connecticut River watershed, so really statewide. So just a few facts and figures for Lake Champlain. Almost half the state of Vermont drains into the lake, and we are the lion's share of the watershed overall. We have almost 60% of the watershed. New York has about a third, and it's largely comprised of the Adirondack Park, and then there's a small portion above that black line that's up in the province of Quebec. This is also a big lake, 120 miles long, more than 400 feet deep in its deepest parts. And as I mentioned earlier, the drinking water source for quite a few people in Vermont as well as in New York. So as part of the TMDL process, we again prepared that pollution budget, looking at where the phosphorus load reaching Lake Champlain comes from. In this case, about 40% of the load is attributed to agriculture, 20% is attributed to stream instability, and if you add up the orange and red slices, about 18% is related to developed lands, whether we're talking about gravel roads or paved surfaces. And then that small yellow swath is attributed to our wastewater treatment facilities, and that's a rather unique aspect of the Lake Champlain TMDL. In a lot of places you hear about, particularly the Chesapeake Bay, that yellow wedge could be anywhere from 20 to 30% of the overall pie. So we've got a really small point source wedge. We also often hear questions about forests being a source of phosphorus. It seems a little bit hard to believe. There is some naturally occurring phosphorus associated with forestry, as well as phosphorus losses associated with the disturbance from log roads and landings. And what's important to keep in mind is forest lands are attributed to 16% of the load. They're 75% of the land area. So it's a very small impact per acre. And as I encouraged you to try to remember the types of reductions we were talking about in Lake Memphremagog, 29%, 40 metric tons. Lake Champlain, we're talking about 34% and over 200 metric tons. One of the challenges of Lake Champlain is frankly the land area to surface water area ratio. I'll go back to the map. This is a really big watershed. It's about 18 square miles of watershed for every square mile of lake surface. And just for sake of comparison, in the Great Lakes, they have somewhere typically between 1.5 and 3.5 square miles of watershed for every square mile of lake surface. And so what this means is we have to do a lot of practices to have the same level of impact in terms of treating the land area draining to the lake. And then just wanted to highlight for you quickly, we say 39% or 34% reduction, but it's not really spread evenly across the different categories. This particular graphic highlights agriculture, which is targeted for a 51.5% reduction overall. You can also see there are significant reductions ascribed to wastewater as well as to streams, and this is sort of the erosion of stream banks largely attributable to stormwater, as well as ag production areas, which we've separated from the ag non-point source category. So these are some really significant numbers, and then they also vary depending on what lake segment. Perhaps the most challenging numbers are in segment number 12, which is the Missisquoi Bay segment, where we see ag reductions on the order of 83%, stream reductions of 65%, and wastewater reductions of over 50%. So these are going to be very challenging objectives to achieve. But we've laid out a plan, and it's a plan we have a great deal of faith in. The first step is our phase 1 implementation plan, and this plan it sort of incorporates a lot of what Act 64 laid out from the legislature, and also highlights some natural resource restoration work we plan to engage in, as well as the ongoing development of what we call tactical basin plans. So that first slide with the 15 major river basins, we have a much more detailed plan for each one of those, developed with a lot of outreach and networking, work by conservation districts, watershed groups, regional planning commissions to engage local stakeholders and help us understand local priorities. Act 64, as I mentioned, is statewide, and we've highlighted 5 key components of it up here. One is some increased requirements for stormwater runoff management. We're going to be issuing a new permit for stormwater runoff management from developed lands by the end of this year, including a requirement that any parcel with more than 3 acres of impervious surface will have to install retrofit stormwater practices to treat runoff from those areas. We've also focused really heavily on road-related stormwater management. All of our models and research suggest that this is a really cost-effective place for us to invest. It has the added benefit of also making our road network more resilient, and that was a big selling point when it came to talking to municipalities about this work. And that's a piece that we've kicked off even this summer with a grant program to hopefully motivate some folks to start implementing road-related best management practices in advance of the permit being issued later this fall. We've also, the Agency of Natural Resources has a strong partnership with the Agency of Agriculture and NRCS, and has a framework for incentivizing and permitting changes on farm operations to promote agricultural stewardship. All of this came wrapped with a number of new and increased fees that support the positions needed to do this work. And we also established a clean water fund. And one of the things we had said all along was there's a real need for consistent, sustained, long-term funding for water quality work. Folks need to know that if they're developing a project that won't be ready to implement for 2 to 3 years down the line, that when the time comes to build, the money will actually be there to support implementation. It's critical to building momentum. The Clean Water Fund initially was, the funding came from the property transfer tax, so it's a small add-on to the bill when folks are selling property. And it was being funded at a rate of about $5 million a year. This year, well, for the next 2 years, the governor has actually increased funding for our clean water work by more than 70%. So that property transfer tax was in addition to our state revolving fund, some existing line items within the state budget that came to my agency, as well as the Agency of Agriculture and Agency of Transportation. But it took us from funding that work at a rate of about $30 million a year to a rate of almost $54 million a year for this year and next year. So now we're faced with the wonderful challenge of getting those resources on the ground in the most efficient and effective manner possible. But the Clean Water Fund has been a key piece of that, and one of the tasks I was assigned by the legislature at the end of last session is to figure out what that long-term funding looks like once we get beyond the next 2 years, because the funding that the governor used is really only available for 2 years. So just to touch briefly on the types of projects that we've committed to in our Phase 1 plan. We've updated the required agricultural practices, or RAPs, and it has a whole set of pieces that fall under that, including increased buffers on streams and ditches, decreasing the amount of allowable soil erosion or tolerable soil erosion, requirements for cover crops, etc. So this is a really exciting piece of this puzzle. Similarly, we made commitments relative to developed lands and roads. I mentioned the 3-acre permit that should be issued this winter. We're also looking at changes to our MS4 permit, and those are permits that are issued to our larger communities, Burlington,